Okay, today's seminar is steam valve sizing and selection. And before we get into the meat and potatoes, the formulas used to size the valve, to calculate the size of the valve needed in order to control the steam flow, are industry standards. They weren't developed by Belimo. They've been around forever. But of course, forever we've had very good success with them. So today we're going to look at a steam system, applications where we use our control valves. Our control valves are temperature control valves. We do not control pressure. We'll look at different systems and then the required information to size a steam valve, which in the HVAC industry is pretty simple. Steam valve sizing, steam temperature control valves, the types of valves that we use for controlling steam, and how to select the correct steam control valve. Then I'm going to show you a tool called SelectPro and show you how easy we made it to size and select the proper control valve. So here is our steam system, and you can see we have a boiler on the left that we have some type of fuel, fossil fuel most likely, boiling water and turning water into steam, and in this case it's high pressure steam. You see 100 psi, which is gauge, pressure, pounds per square inch gauge. And the red indicates steam, as you can see by the little square blocks. And the blue indicates condensate and the yellow vapor. So when we deal with steam, we're dealing with all these different conditions that handle very differently. And on all systems, as you look at the cookers that we have here, the heating tanks, and then on the very right, the HVAC system, you'll see steam traps. Steam has to be trapped. And the steam trap can be, there's various steam traps. It just holds back the steam until you turn the steam to a condensate. So on the outside of this trap, you're always seeing blue. But we're not here to talk about traps. We're here to talk about control valves. On the main steam line there, we see a PRV, a pressure reducing valve. And in my example, which is a little extreme, we go from 100 psi all the way down to 7 psi. In HVAC, it's very commonly used the maximum 15 psi, although some of our HVAC systems may be higher. Generally, we use 7 psi, maximum 15 psi. And by most codes, 15 psi indicates low pressure. Greater than 15 psi will be either medium or high pressure. And then you can get into licensing and whatnot, how that changes. Steam is an invisible gas generated by adding heat energy to water in a boiler. Steam is also one of the best agents known to take heat from one source in one location to form a service at another location. So if you have a hot water system, you might want to make your hot water at a different location so you don't need all the pumping. With steam, no distribution pumping is required. Now you might need pumping to get some of the condensate back to the boilers, and then there's also gravity systems. And again, you see the red and then the blue. You can see before the PRV how you have to constantly drain a steam system. You don't want to cause water slugs, so everything's draining back through the traps and then eventually back to the boiler. There are different types of applications, and one of the most common is heat exchangers, steam to water heat exchangers. Now, I put this picture in and I have one valve on the inlet side. The steam valve is always piped. It has to be piped on the supply side, unlike our control valves on hot and cold water where we generally pipe on the return side. And you might have two valves in there, which we commonly refer to as a 1/3, 2/3 system. But on this heat exchanger, I just used one valve. And you can see the steam through the tubing and the water through the body side of the exchanger. So we're heating water and sending it out to some type of load. Different other applications would be preheat and reheat coils, maybe in a major air handler unit. Fin tube radiation, there's still a lot of steam used. Fan coil units, basically the same, unit ventilators. Again, this is pretty redundant. Unit heaters. Unit heaters is interesting. That's one of the places I will see high pressure steam in unit heaters. Not always, it could be. Sterilization, not too common in our HVAC world. Hot water storage, yes. And then humidification, which is interesting. That's the one time that through the process you will not use a trap. You're constantly draining the condensate, but you're actually putting the steam vapor into the airflow to humidify. So we're going to control by temperature. We don't control pressure. That's a totally different valve, a pressure reducing valve. We control temperature. And it's pretty simple. For our end of sizing, we need to know the steam flow in pounds per hour. If it's in MBH, it's easy to calculate the difference. And the inlet pressure, the steam inlet pressure, and that would be at the inlet pressure designed for the unit. And pressure drop for modulating steam, we use 80% of the inlet steam pressure unless otherwise specified, which you rarely will see. Most sizing calculators that we find online on the Belimo website will take the pressure drops automatically, and they use industry standard numbers. To select the steam valve is a little different. We'll want to know the voltage, what's controlling it, what's the control signal, is it modulating or is it on off? And then most definitely with steam we need the normal position and the fail position. The normal position is with no signal. If we lost our control signal, then we want the valve to go open or closed. The fail position is on a power loss. If the voltage goes away altogether, do we want it to spring open? Because now in steam, a lot of times the steam system will still be up if the power is down. So in the Northeast at any rate, you might want all your steam valves on primary heat to be opened so you don't freeze a building. So that's some of the things. It can get more detailed, but I wanted to keep this end of it basic. And a lot of times we're needing a spec that an engineer wrote, and this should be enough to select the steam valve. Two-position steam, very commonly done as line size. If you are going to size it, you take a 1 psi drop, so a 10 psi, you would take a 1 psi drop. I've known a lot of rule of thumb type guys who would go down 1 line size. In other words, if you have a 2-inch steam line going into an air handler unit, they would use an 1.5-inch valve. I've never had a problem with that because it's usually more than big enough. The pipe size is always going to be bigger than the control valve size. And the math here, the steam example, this is the mathematics to calculate the CV, CV being the coefficient of volume, the actual size of the orifice or the cross-sectional area that the steam is going to pass through. And there's your formula, which we're not going to get into. But here I have the example with 15 psi inlet. You need to know the inlet pressure, 200 psi, 200 pounds per hour, and this is an on-off application. And we look on the calculation, you can see they're using 0.1 as the pressure drop, so you have a 1.5 pound drop. And the reason we're not going to get into this is because it's so much easier with calculators. If you want to see this, it's in the back of our price guide and product list. So the PGPL, the Belimo PGPL, or on belimo.us, all of this information is there. Proportional control of steam, we use 80% of the gauge pressure for the pressure drop when we do our calculations. So to calculate a modulating application, what they teach us is to use 80%. So on 15 psi inlet, we would take a 12-pound drop, which is pretty dramatic, but the math works out. Yeah, greater than 15 psi, you use a 42% drop. And today we're going to talk about low pressure steam mostly, but we could do high pressure steam. And with the calculators and whatnot, it's very simple. But this, over the years, has confused people. Why do I take that drop? I was at a Con Ed seminar and they explained, which I've always lived by, that's the way we can modulate steam. We're trying to control temperature. So again, here's our math, and instead of taking 0.1, we're taking 0.8 of the inlet pressure or a 12 psi drop. And we calculated a 2.29 CV, the actual size of the valve. That's going to be a small valve. The easy way, steam calculators. If you don't have a steam calculator, you can find them online. You can contact a Belimo district sales manager or your Belimo distributor, and we can get you as a calculator. And this you can see on the where it's LBH, pounds per hour, in the big square on top of the big square, and MBH on the other side. So either way, you just plug in your pounds per hour, you plug in your inlet pressure, and it calculates a CV for you. These tools usually will have a capacity calculated, calculated CV charge for pipe factor. So they're handy little tools, but right now, just for steam, we need to calculate a CV. In this case, on the 6,600 pounds per hour, we calculated 190.34 CV, which would be a 4-inch valve. So it's pretty simple this way rather than doing the math. Steam temperature control valves. Now, not all valves work on steam. And again, we have steam valves for low pressure, which would be lesser than 15 psi, or HT, CCV, high temperature characterized control valve. Our globe valves with the bronze or the stainless steel trim. Medium pressure, some areas will just say high pressure, but medium pressure 15 to 50 fits some of our applications. And it would be our globe valves up to 30 psi with bronze, and then 100 psi with stainless steel trim, because the trim is a wear factor. A lot of velocity with steam. Steam travels very fast. Butterfly valves, now that's kind of unusual. Only the high performance butterfly valves, and they would only be used for isolation and up to 50 psi. High pressure, we have our V-balls and our stainless steel trim globes. The globe valves come in different configurations for different pressures. And up here I have the G6C. This would be valves 2.5 through 6 inch. And the C valve means compensated, so it's compensated on a close-off with very high close-off pressures. The G6CS series would have stainless steel trim. The S is for stainless steel. Then we get a little more complicated. The G6LC and the LCS, linear. Linear valves are commonly used in steam applications and commonly only for high pressure. A lot of engineers and a lot of users like to use equal percent valves on low pressure steam to get better control of the lower flows. So there's two schools of thought, but we do have the linear valves when the engineer specs linear on the larger product, and that would be on high pressure heat exchangers. We also have those valves available in ANSI 125 and ANSI 250 for higher pressure applications. So the spec sheet on the G6, the G6CS and LCS, and I put the arrows there because we're not going to worry about anything but steam. And it says the G6C is good for maximum inlet of 35 psi, where the CS, the stainless steel, is 100 and the linear stainless is 100. And then it gives you the temperatures. Now, temperature and steam are totally relative. One thing that always makes it easy for me, and I guess anybody who worked in steam a lot, 15 psi is 250 degrees, so it makes it pretty easy. But that steam there on the G6C says 32 Fahrenheit, 280, 32 Fahrenheit to 280 Fahrenheit. That's the temperature of 35 psi. And on the stainless steel trim, 338 degrees is the temperature of 100 psi steam. Then maximum differential pressure. Most of these valves on the low pressure side will close off at the complete inlet pressure. Like in this case, if you had 15 or less, it closes off at 15, so you're very safe. This is the threaded product, the glow valves, the threaded product, and it's the same thing. We got the stainless steel. I got up on the top there, I have G2XX, then G2XSS for stainless steel, broken out left and right. The bronze trim is for the lower pressure product up to 35 psi, whereas the stainless steel trim, we can go up to 100 psi. Great little product, 1/2 inch through 1 inch for small units. It's very small. It's our HT, high temperature characterized control valve. So we used a ball valve in a steam application, great for fan coil units and unit ventilators, cabinet unit heaters and whatnot. And again, this valve, maximum inlet pressure 15 psi, that's it. But generally that's what we're going to see, and maximum differential pressure 15 psi. The close-off pressure, they have rated at 200 psi, so that's obviously not an issue. And there's that media temperature range at 250. High-performance butterfly valves, again, these are only what we call, a Belimo rep might call an SHP valve, a high-performance valve. And they're a stainless steel trim retained valve with Teflon trim. And again, you would use this for isolation. So the tech sheet on this, when you get to steam, is not too complicated. Steam up to 50 psi, and that's about it. So to calculate, selecting the correct control valve, I have to calculate a CV. I need to know the pounds per hour. And that generally will be on the equipment schedule. And they'll say this air handler unit is 6,000 pounds per hour, and the steam inlet is 8 psi. To select the actuator, we have to know the voltage, the control signal, is it modulating or on off, the normal position with no signal, and then the failed position like we went over before, and possibly the close-off pressure. Belimo has this tool to size and select. As far as I know, this is the only one there is, and it's a fantastic tool. Going back to maybe the 80s and 90s when we did valve schedules by hand, and then we got the Excel tools, this is a very, very powerful tool, and I'm going to do a quick selection. SelectPro is a lot stronger than just valve sizing for steam. And there will be a webinar on June 8th going over SelectPro and all its power. So I'm going to get out of here, and I'm going to open SelectPro, which can be found on www.belimo.us, and you download it. Takes a second to open. And you see these different selections you have here. But again, we're not going to go through that. We're going to talk about valve sizing. And that's the screen you get for valve sizing, water or steam. And there's a lot of things you can do here. And the more you know, the easier it's going to be. It's going to be very easy to select the proper valve right away. And first thing I have to do here is change water to steam. And because we talked about this, I also have to change the control because we know they size differently. And we're going to say modulating. So now I'll put in my numbers that we were blanked out of there before. It wouldn't let us put it in until I changed it to steam, and the control I had to change to modulating. And I'm going to use 500 pounds per hour as my load, and my pressure is going to be 8 psi, and once I hit tab, it calculated a CV for me, 16.32 CV. We refer to that as the calculated CV. And the rule of thumb in the industry is to select the closest valve up. So you go up, if you went into a book, you would look at what valves are available for steam, and you would select the closest one to 16.3, but you would go up. But now this was specified, and the engineer told us he wants globe valves. So up here, I could select globe. Oh, before I do that, you could see down here it selected the V-ball, the high temperature characterized control valve, the two standard ball valves, and two low valves. But again, the more you know, the easier this gets. And this engineer wanted globes. Let me give you the full view on that. So you can see I got a lot of fill on valve parameters. It's a two-way. It's anti-250. The body size is 1.25 inches, and it's threaded. And this engineer also wants stainless steel trim. Okay, now what I'm looking at down here, I'm down to one valve. But before we go into the actuator, I want to show you this. For people who do calculated CCV or FP pipe factor, say you had a system and it selected a 1.25 inch valve for this unit, and they said the pipe was 6-inch pipe. Something's wrong. We got to go back to the drawing board. So we stop you there and say, check that out. So now I took all my information out, but if I change this back to 1.5 inch pipe, there I am. And for some reason, it dropped out my trim. So I'm going to select stainless, and now we're going to start collecting control signal. Just about everything you could possibly need. And the most standard would be MFT or configurable, which will be a standard 2 to 10. That can be programmed to 0 to 10 for any control signal really that you need. But if you had it on off, you can choose on off, floating point. 3 position is the same thing. It's very complicated here, and it shouldn't be, so we'll just select MFT, which is going to fall 2 to 10 VDC. Safety function, we have a lot of options, and I'm going to choose spring return. NEMA rated if needed, you just drop it down. Built-in auxiliary switches, not too common. Sometimes you might lock out a fan. Voltage, that's the most common. And close-off pressure. Now, when I scroll down, I have to select my valve, and you see that all loaded. You have to click on the valve. It loaded, and it's telling me I have a 236 psi close-off, and all we have is 8 psi, so we're not going to worry about that. And because I put in a lot of data, it selected one actuator. And that is a list price. Don't let that scare you. We do not sell for list price. See down here you can see show prices and notes or show selection criteria, but it will keep the list price in that area. So I have my valve selected, and I'll put it into a schedule, which takes a second sometimes. There it is. This is very cool. I have it into a schedule that I'm going to show you how to change into an Excel schedule. But if you need that, if you need submittal sheets where it says data sheet, you click on it, and there it is. And there's my submittal sheet, the valve end and the actuator. And we always add the wiring. Very simple Belimo wiring. I'll close out of that. But of course you could save it if you had to submit it. I'll close out of that and get rid of this, and we're back here. So the next thing I want to show you, and again, there'll be much more detail on this, if I want to save this as a valve schedule or a quote, the way I'm saving it now, because of I'm showing selection criteria, will be a valve schedule. We seem to be talking like we're working with an engineer. Export to Excel. I want to know where I want to save it, and I'm going to say on my desktop and hit save. Yes, I did a practice run. Now this screen, if you had water valves and pressure independent valves, this is just saying you want to put them all on the same schedule, and we'll say yes. This takes a second. And of course, we could have done this process with high pressure steam, but in our HVAC world, we generally work with low pressure steam. Okay, there it is. Now, this as a schedule, I could have had all my information in here, you know, what the company was, their address, the people we were dealing with. And some of these cells, this is the cell that the data sheet is in. Generally, when I send this to an engineer, I just delete these cells to make it neater. But you know, that's again up to the user. But now I have all my sizing information. It's telling my control signal, my voltage. It's a two-way valve. The pipe size is 1.5 inches. The flow is 500. The inlet pressure 8. And there's our calculated CV, which sometimes the engineers like to see. The body size is 1.25 inches. The valve CV is 20. Close-off pressure again. We talked about that. And there's our part number with the actuator number. So pretty cool stuff. If I would have did in the quote form showing prices, it would have had the list price, and then it would have had, if your distributor or if you're a contractor with a multiplier, you can plug in your multiplier. Again, there will be a June 8th SelectPro presentation. Today's presentation was selecting a steam valve. But all in all, this made it pretty easy. And then again, if you need help loading this, or with any application, if something's confusing, you could contact the district sales manager or a Belimo representative, and they can help you. Okay, that's about it. And I guess Michaela?
Yes. All right, Bob. Thank you so much. Bob, could you just pull up your PowerPoint? There we go, that slide. There we go. Perfect. So I do have a bunch of questions for you. Audience, if you want to listen in, I know we're running a little bit over time, but if you want to listen in to the questions, you're more than welcome to. And if you have some questions, please feel free to type them in. I will read them aloud, and Bob will answer them as best as possible. And if we don't get to everyone's questions, we surely will get to you and make sure that we give you the appropriate answers. So first question. Bob, are you ready?
Yes.
Okay. Are these valves slow closing, which prevents steam hammering?
Yes, anywhere from 90 to 150 seconds. The springs are about 20 to 25 seconds, but we've never had on a failure, we've never had an issue. They're plenty slow enough to prevent hammering.
Okay, next question. Your sketch for a heat exchanger shows steam in the tubes and water in the shell. Normally, we have steam in the shell. Isn't this true?
Yes, that's what I found online.
Oh, so you're blaming someone else, right, Bob?
Yeah, absolutely. Yeah, I mean, it could be either way, and I think what I showed is more process, because there's more process stuff that you can pull offline. But yes, absolutely.
Okay, this is a two-part question. Please clarify when you stated that pressure drop is assumed to be 80% of the system pressure. Is this the PD of the valve or device? Also, is the PD across the valve 80% or 10% of the inlet pressure?
Okay, on modulating steam, it's 80%, and that's the one that's the important one. It's 10% on the on-off applications, but let's talk modulating because that's by far the most important. When you have a steam schedule, the schedule is going to give you the rated pounds per hour of the coil and then the steam inlet pressure. That's the steam inlet pressure. If it's 12 psi, you have to take 80% of 12, and that's the assumed pressure drop. And why it's so confusing is that when you do the math, if you go through that math, when you use PO or P2, which is the outlet pressure, you're adding 14.7 in the Northeast absolute to it. It's changing the PSIG to PSIA. But steam is kind of confusing, and again, that does confuse people, but that's how we calculate that we can modulate steam. And we've never had success for it. The other thing to keep in mind is steam will actually travel negative. Steam is a gas, a vapor, a condensate, and it will travel negative to the trap. So in order to modulate, yes, we use 80%. And the person who asked this question, you could find data online also from a lot of industrial sites.
Okay. Next question. On the steam to hot water heat exchanger diagram, isn't it more common to provide steam in the shell and pump water through the tube? So unfortunately, we already answered that question.
Yes, we answered that question.
What does the disclaimer for proper CV calculation, valve, and pipe size mean in SelectPro?
I gotta open it. Okay, just give me a second. I wasn't ready for that one. Oh, they want you to put the, you know, I actually went through that. They want you to put this pipe size in, and again, it's because of pipe factor, that if you're reducing that many times, there's two schools of thought on that. Some people say that it doesn't matter with steam, that you can go from 6-inch to 1-inch and you don't have to do a pipe factor calculation, which is a lot of math, or you use a calculator. And what it's saying that I have a 1-inch valve with a 20 CV, and my inlet pipe or my outlet pipe is 6-inch. It's going to change that CV from 20 to maybe 16 because of the decrease. So that's what that's saying. But on the other hand, there are people who say that's not true. I don't agree with that. I agree you should do your calculations, your calculated CV. But like I said in my presentation, if you have a coil that has a 1-inch inlet and somebody ran a 6-inch pipe to it, you have to wonder why. Because there's only so much steam that will go through an orifice at a specific pressure drop. So when you really study steam, you can see there's a quantity of steam that you can get through a specific cross-sectional area at a specific pressure drop that you want to maintain. So that's what the disclaimer is, that if the pipe is real big, like I did, it's not going to allow you to select the valve. It wants you to go back to the drawing board.
Okay. Is there a rule for sizing steam valves? Oops, sorry. Is there a rule for sizing steam valves when you don't have a steam flow, but you have an inlet pressure and a line size? For example, if you are switching out an existing valve.
If you're changing out an existing valve and you have no information, do the research, or call a Belimo rep, and we'll try to calculate what the existing valve was. So in the bigger product, the 2.5 through 6, it's pretty easy because the CVs are all the same. On the 1/2 and 3/4 and 1-inch, it can be a little tricky, but that's all we have to go by. Unless we can get the part number from the old valve, then we can look up the CV. If you have no information, no, there is no rule of thumb. I know this is not as a Belimo rep, this is as an ex-pipe fitter. I know what they'll do. They'll go down one pipe size. And there's no accuracy to that whatsoever. But sometimes it's what you have. So that was a 3-part answer.
Okay, next few questions. What is the applicability for a 0.5 to 2 pound steam as commonly used in the Northeast or in high-rise buildings?
Point 2 pound,
No, I'm
PS
sorry,
0.2 pound.
0.5 up to 2 pounds.
Well, that I don't know if I can actually address that question, but it is an interesting question because, again, steam will travel. Low pressure steam, without getting crazy about this, if you do your research on it, travels faster than high pressure steam because of the size of the molecules. And old systems, when you look at the old systems, they were designed for 1 or 2 pounds of steam with these gigantic headers, and you just wanted it to lift and go out through radiators and whatnot, and then come back as condensate through traps or a vacuum system. So that was the concept. The 2 pound steam or the half pound steam is more around 213, 212 degrees, 215 degrees maybe. It's safer. It's not as hot. And you don't need 250 psi, 250 Fahrenheit to heat with. 212, 213 is, you can make some comfortable heat. So that's the only logic I can see. But I do, especially the older systems were designed for low pressure.
Okay, a couple of individuals are asking where can we download SelectPro. If you go to www.belimo.us, there's a sizing and selection tab, and you can actually download SelectPro there. And as Bob said, we will be having a webinar on June 8th, and it's all about SelectPro and the recent updates. Last question is, does SelectPro actually change the calculated CV when I change the pipe size field?
No. We can talk to our people about that, but it does not do the corrected CV.
Okay.
And if we have a moment.
You can have one more moment.
I figured that. Let's put our numbers in. Oops. 500. I'm trying to go fast, and I'm not doing a good job. And there's our CV. And we'll select the globe out. And let's put in something more. See, it selected. No, it did not correct it. And you would think 2.5. Well, let's go up one size. And now it's just telling you you should do that. You should consider that, or contact us. But on my PowerPoint, I hope I'm not making people dizzy doing this. There it is. Right here is the C sub E chart. So you put in the valve size. Well, let's look at that very first one in the CV chart, where the 1-inch valve and the 2-inch pipe, a CV of 43 turns into a CV of 25.8. And again, there's two schools of thought on that. Some people say you don't have to do it, and some people say you have to do it. But there's a CV, a calculated CV chart. And they're also in the Belimo catalog. Okay?
All right. Well, thank you so much, Bob, and thank you everyone who sat on the call and asked those questions. Unfortunately, we were not able to get to everyone's question today during the webinar. However, we will be in touch with you to make sure we give you the proper answers. As always, I thank you so much for attending these webinars. We love putting them on for customers and educating everyone and answering questions. So we will see you at the next webinar, which is on June 8th, and it will be SelectPro and recent updates. Thank you very much, everyone, and thank you so much, Bob. I hope you all have a wonderful day.
Thank you.